Okay, guys, 1-4, day 2. We are moving along. Look at this crazy symbol. It's called sigma notation. What the heck is it? Well, that's what I'm getting paid the big bucks to explain to you today. So look, it's a formula and it's a set of instructions. Sad if you're on this test and you're like, oh my gosh, that's way high level math. When you break it down and you just understand the instructions, it's pretty simple. So with all that being said, when you look at this, it's an actual question, but this is the generic, general formula for it. That number up there, letter N, is the number of terms in a sequence. We've been talking a lot about sequences. This is how you can apply one of these crazy ideas to sequences. This right here, says right here, it's an equation using I. So you can look down here on this problem, N equals 9. In this problem, your equation you're going to use is 2I minus 6. Now you guys are used to using x's. Now they're going to have you use the letter I as your variable. Don't sweat it. And I equals 1, that's going to be an always for this class. So essentially they're saying, hey guys, all the way from 1 to 9, find f of 1, 2, 3, 4, 5, 6, 7, 8, 9. And then take the sum of it all. Now I know this is a stretch, but I said find the sum. This Greek symbol is a real, I know this is a big stretch, but I'm going to put the letter S in there. Does that make sense? Not really, but maybe even that will help you remember. That's what it's really asking you to do. The sum of what? I'll show you. If I put 1 in for I, 2 times 1 is 2, minus 6 is negative 4. Put 2 in. 2 times 2 is 4. 4 minus 6 is negative 2. Put 3 in. 3 times 2 is 6. 6 minus 6 is 0. Are you seeing the arithmetic sequence? It's going up by 2. So you can go ahead and cheat and just fill these in and take advantage of the fact that you realize there was a pattern. Now, what's the answer to this? Remember, I put that S in there. It doesn't really make sense because that Greek symbol doesn't really make an S, but maybe it'll help you remember. But I just add it all up. Now I'm going to say, hey, that's a negative 6, and I know this is a positive 6, so those cancel. I'm going to add these up. 0 plus 6 is 6. 6 plus 8 is 14. Plus 10 is 24. Plus 12 is 36. That is my answer to that crazy original problem. All right, is there a shortcut? Glad you asked. Remember, they want the sum of the sequence. Well, we've talked about this formula right here. So they want, because n is 9, I know I'm interested in the sum of all the first 9 terms of that function. So I stick in 9 for n. My first answer for this situation is F1. That's telling you what's your sum, what's your solution after you plug in 1 in for I, negative 4. And what's your solution for your final term, which is our 9th. When we plugged in I is 9, we got 12. Put that over 2, and I'm going to go ahead and go 2 into, well, I'm not going to do that. Sorry about that. 9 times, forget that I even scraped those out. That is negative 4 plus 12 is 8, divided by 2. That's 72 divided by 2, and that's 36. Notice, same answer. Shortcut. All right, I'm going to hit pause. We're going to do some story problems on the document camera. Okay, so we're going to continue on. Here's the deal, you guys. We're going to do 2 story problems. They're similar but different. And that's going to be your big challenge. What do I do when there's these little subtle differences? Also, there's this new phrase that's going to get thrown at you, explicit definition. The explicit definition in its generic form is right here. Now, we'll come back to that in a minute. Let's read this problem. A high school auditorium has 18 seats in the first row, 26 seats in the 5th row. The number of seats in each row forms an arithmetic sequence. Now, here's the thing. I want you guys to know something. The letter D stands for the common difference. So if we're going to use this formula, we need to know what that letter D is. Now, I'm going to take a look at the next example we're going to do, example 6, and talk about the letter D. Similar problem. You know, they're talking about seats in an auditorium. This one is a pyramid of cans is on display at a supermarket. The top row has 1 can, second row has 2, third row has 3. There are 10 rows. Now, remember what I said. D is the common difference. Look, top row, 1 can. Second row, 2 cans. Third row, 3 cans. Pretty obviously, there's a difference of 1. From 1 to 2 is 1. From 2 to 3, 1. So on this problem, we can just read it and go, aha, D is 1. On this problem, because it jumps from the first row to the 5th row, and there's no way I can make a connection, I don't know what D is. Please keep that in mind. That's like the major point, okay? So this problem starts out by saying, what is the explicit definition? What that means is, of the sequence. Find this equation. Now I've pulled the pieces out where A sub n is the number of seats in a particular row. For example, if this was 18 seats in the first row, A sub 1, like right there, would be 18. If the 5th row has 26, then A sub n would equal 26, and that's all we know on this problem. But it's asking us, hey guys, get started by just filling in whatever you can here. It's like, okay, I know what A sub n is. We just talked about it. What we're talking about here is the 5th row. So the 5th row has 26 seats in it. The first row has 18 seats in it. We do not know the common difference. See, that's what D stands for, the common difference. Remember, we just can't see it in this problem. That's what I'm trying to point out to you. If you can't see it, then you must find it using this generic formula. And then we also know that we are interested in there's 26 seats in the 5th row, and that's what n is. What number row are we interested in? We're talking about the 5th row, because that's why we put a 26 in there, minus 1. Now look, we got this little formula that will help us find D. So 26 equals 18 plus 4D. Subtract 18. I'm going to do a little math in my head here. Whoops. I paid for it. 8 equals 4D. So D equals 2. Now that I know that, they're asking, what is the explicit definition? Well, now I can actually plug in D equals 2, and here it comes. Here's the answer for question letter A. Plus 2 times n minus 1. What that means is I have now figured out a formula that if they ask me how many seats are in the 6th row, 7th row, 8th row, 9th row, I can use this formula to figure it out. And let's demonstrate that. This says how many seats are in the 12th row. So all I'm going to do is take this formula. I'm interested in the 12th row, which is just a simple way. I just put 12 in for n, and that's just saying let n equal 12. The number of seats in my first row, we already know that. We already know that to be 18. And we found D to be 2. That's why it was so important to figure that out. N is 12, because we're interested in the 12th row, minus 1. And now it's just a crunch it out. PEMDAS, though, don't go 18 plus 2 is 20. We got to figure out what this is. And so now we know it's 18 plus 22, which is 40. There are 40 seats, now listen to me very carefully, in the 12th row. They did not ask us to find the sum of all the seats. Keep that in mind. They wanted the number of seats in the 12th row. So we're done. All right, before I go on to the next problem, I'm going to pause this. Okay, so here we go. This problem says a pyramid of cans is on display. We already read it, so we have a stack of cans, okay? Notice on this problem, you can determine the common difference of D is 1. So we know right away D is 1, which means we can take that and pop it right into this generic formula, and we have this formula, A sub n equals A sub 1 plus 1 times n minus 1. So this is now a formula that will allow us to find any number of cans in any particular row. But let's read the question. It says, if there are 10 rows of cans, how many total cans in the whole pile were used to make the pyramid? So this is a different question, which means we must use this formula, which means we got to know what n is. And in this case, there are 10 rows, so we know n is 10. In the first row, we know there's 1 can, and we're worried about or concerned about how many cans are in the 10th row. See, we don't know that, but we need that to use the formula. So that's where we're going to use this formula. So to find it, we're going to go A10 equals, how many cans are in the first row? 1. We already know what 1 is, because that's our D. We're worried about the 10th row. How many cans are in the 10th row? So my 10th row has 1 plus 9 times 1 is 9, 10 cans. So look, guys, if we're going to find the total sum now of all the cans, we can use this formula. What is n? 10. How many cans are in my first row? The top one, 1. How many are in my 10th row, my final bottom row? That's 10. And now we're just going to divide that by 2 because that's part of the formula. And so let's do the math. 10 times 11 over 2 equals 110 divided by 2, which is 55 cans in the entire pile pyramid. Remember the difference. This problem wanted total cans in the whole pyramid. That's why we had to use the sum of every single row. On this problem, they only wanted information about a particular row, the 5th row. That's why we had to come up with the formula by finding D, and then we use the formula plugging in the necessary information. These are similar but different. All right, now I'm going to hit you with a couple more sample problems if that's still a little rusty, but keep those ideas that I've been emphasizing clear in your mind. All right, guys.